All right, so today we're tackling Kioptrix Level 2, but this isn't going to be your typical walkthrough. We're going to use this box as a training ground to build a disciplined, repeatable methodology. See, the goal isn't just to pop this one machine, it's to forge a workflow you can take with you to any challenge.
And we're starting right here, with a feeling that I know every single one of us has had. You've spent hours, literal hours, chasing a ghost. You're working on the wrong IP, or you're poking at a vulnerability that isn't real, and you're just convinced you're on the right track. This whole explainer, it's the cure for that specific kind of pain.
So let's be really clear about this. We are not hunting for some magic command that solves everything. No way. We're building a calm, evidence-based workflow. This is the antidote to what the source calls hope-driven clicking. You know, that chaotic state where you're just trying stuff until something, maybe, hopefully works. We're going to replace hope with proof.
And the core of this entire mindset is something called the proof ladder. Think of this as the mental model for the whole process. It's how you build momentum that you can actually trust, step by step.
Here are the 5 rungs of that ladder, and each step is basically a claim that you have to prove before you're allowed to move to the next. You find your target, and you prove it's the right one. You find services that actually tell a story. You pivot to the web and find a behavior you can actually influence. You turn that influence into a shell, and then only then do you use logic to get to root. It's a clean, structured path.
The first rung is maybe the most important, and it's the one people rush past all the time. It's discovery proof. It's a simple declaration. This IP is my target. But you don't just believe it, you prove it with tools like ARP and ping. This single, simple step can prevent hours of wasted effort on the wrong machine.
Okay, next up, service proof. Look, it's not enough that a port is open. You need to prove that the service on it is real, that it's reachable, and that it's responsive. You're looking for a banner, a version number, something that talks back and confirms what you're seeing. This is how you move from just knowing the machine exists to understanding what it's actually running.
Now, vulnerability proof makes a really crucial distinction. It's not that something just worked once. No, it's proving that your input changes the system's behavior in a controlled, repeatable way. Can you predict the outcome? If you can, you have proof. If you can't, well, you just got lucky.
So once you have that vulnerability, you need shell proof. And this means you have a stable, usable foothold. A shell that dies the moment you touch it, that isn't proof. The real test is running basic commands like who am I and pwd and getting a reliable response every single time. Now you've established a beachhead.
And finally, the ultimate goal, privilege proof. You are not root just because you think you are. You're root when the system itself tells you you are. The definitive, undeniable proof is UID equals 0. There's no ambiguity, you've climbed the ladder all the way to the top. Okay, so with that mindset established, let's actually walk the path. We're going to see how this proof ladder applies in practice, starting with the initial scan and pivoting into the web application, which is where Kioptrix 2 really starts talking to us. So when you get your Nmap results back, your job is not to just count the open ports, it's to find what the source calls story ports. You got to look for the clues, an older service version, a weird configuration. The hint for the endgame is often some small detail that suggests a plausible weakness, not just a wall of data. So, you find a login page. How do you know if it's a broken authentication mechanism or a potential SQL injection? Well, the key is to use evidence to decide. You'll look at the signals. Is the behavior all over the place, totally inconsistent? It's probably just a broken off bug. But is it predictable? Does the same input give you the same response pattern? Can you control the output with little tweaks? Now you're building an injection hypothesis. You're gathering vuln proof. And when you think you've found something, like a ping utility that seems ripe for command injection, you test it methodically. You don't just jump straight to a reverse shell and hope for the best. No, you take these tiny, verifiable steps. Does my input show up in the output? Does it look like the operating system is involved? Can I run something harmless, like ls? You build that proof piece by tiny piece. And this is exactly why it matters. This quote from the source material is just perfect. A proof-first approach stops you from that universally frustrating experience where a fragile shell works for a split second and then just vanishes forever. It saves you from your own impatience. Okay, so once you have that initial shell, the whole game changes. We're moving into the end game now, where the focus shifts from just getting in to stabilizing your foothold and choosing a privilege escalation path based on cold, hard evidence. So before you do anything else, you practice good hygiene. Run these first 5 commands.
Find out who you are, where you are, and what kind of system you're on. This isn't a victory lap. This is the data gathering you absolutely need to build the case for that final rung on the ladder, privilege proof.
And let's talk for a second about why shells die. It usually isn't magic or some kind of bad luck. The reasons are totally diagnosable. Almost half the time, it's just wrong callback details. Maybe your NAT is confused. Other times, it's firewall rules, or you're just dealing with a fragile, non-interactive session. The point is, these are problems you can troubleshoot, not mysteries. So, before you even think about escalating, you go shopping for facts. This prep list is your guide. What's the kernel version? Do you have a compiler on the box? Where can you actually write files? See, privilege escalation isn't a guessing game, it's a matching problem. You match the facts about the environment to a plausible exploit.
And this brings us to the real takeaway. This was never just about Kioptrix. It's about building a portable, repeatable workflow that you can take with you to any other challenge you face.
To help with that, the source material identifies 7 common time wasters that, let's be honest, everyone runs into. We're going to look at a couple of the big ones, and you should think of these not as failures, but as universal tuition fees that everyone pays at some point.
Here's a classic, the disappearing shell. You get a connection and then poof, it's gone. The first impulse is to blame the payload, right? To try 12 different one-liners. But the forgotten variable is almost always reachability. Can the target actually see your machine? Test the path first.
And my personal favorite, mistake number 6, skipping notes because you think, oh, I'll remember that. You won't. As the source says, our brains are just not built to remember complex command sequences when we're under pressure. Your notes are your external memory. They are what allow you to maintain momentum.
This is how you turn frustration into real progress. This table reframes failure. A symptom isn't a dead end. It's a piece of data. You can't find an IP? Check your network mode. Your shell connects and then drops? Verify your callback path. Each problem points to a likely cause and a fast, logical fix.
So we'll end with a challenge. Forget about getting root for a minute. Find a new box, and in the next 15 minutes, just try to complete only the first 2 rungs of the proof ladder. Confirm your target and identify the story ports. The ability to do just that and then stop to form a plan, that is the real skill. That restraint, that's a superpower.